cumulative continuous models a continuous random variable, or it follows same properties as a continuous random variable. To find the area, to find the probabilities, you have to find the area under the curve. But because the function for the normal curve, because this function is really weird, well, if you try to integrate, which basically using the calculus that you know, to find the area under the curve, it will be quite difficult. All right. So basically, what you expect it to do at your level is to use your calculator to find the area under the curve. So you're still finding the area under the curve, but you're using technology. So what I'm trying to say here is, to find the probabilities, we use the built-in normal CDF and just enter the limits and parameters. So use the built-in normal CDF and enter the limits and parameters. So what you need to do is basically from the distribution that you're given, you can see in this question that the mean is 3 and the standard deviation is 2. So just go on your calculator and then use the inbuilt normal CDF. Just gonna clear that. So second variables, then you'll get normal CDF. All right. Just to explain a few things here. If you go onto this, normal PDF is used to draw the graph, all right, of the normal curve. Normal CDF, we use it to calculate the probabilities. So normal CDF, and then the lower bound here will be 1. The upper bound is 3. The mean is 3. And then the standard deviation is 2. And then you'll have your probability. So we can say that probability that x is between 1 and 3 will be equal to 0.341. Okay, here's another question. Given that x follows a normal distribution with parameters 3 and 2, calculate these probabilities. Now, there are just a few things that I want to, because we are using technology here. Remember, you have to put the lower bound and the upper bound to get the area under the curve. So you need to plug those limits into the calculator. So how about if you just have an open interval like this? Then what you need to do is you need to define those limits. Without those limits, you cannot get the probabilities. So what basically I'm trying to imply here is use very large upper and lower bounds. All right, if you have situations like this, use very large upper and lower bounds. Or I can just refresh this and say lower bound values. Okay. Now, for example, you can use for the highest limit, right? If you want to find, for example, the probability that x is greater than 4. So you have to define the highest limit. Now, the highest limit will basically be the largest value that the calculator can handle. And the largest value that the calculator can handle is 1 times 10 to the power 99. So this is the largest value that the calculator can handle. So instead of using that, in the calculator, you can just plug in E99. I'll show you how to do that. All right. I'll show you how to do that. Let me just finish these descriptions and then explanations. Then I'll show you how to do that. So if that represents the largest, then -1 times 10 to the power 99, that represents the lowest value that the calculator can handle. Great. Now that we know that, we can go ahead and find the probabilities of these guys. So let me start with the first one. A probability that x is less than 2. Remember, these are cumulative probabilities. This is a continuous random variable. So what you need to know is go and find where normal CDF is. That's a guy that we need. Great. Our mean is 3. Standard deviation is 2, so that's all sorted. The lower bound here is the lowest value that the calculator can take. So you can put in -1 times 10 to the power of 99. And then the upper bound, you can just plug in 2. And then you'll have your answer. 0.309. Alternatively, what I usually do is this. So instead of plugging in -1 times 10, this is basically what I usually do. Normal CDF. So instead of plugging in that, you can just go negative shift E and then plus 99. It's easier. It's the same thing, all right? If you plug in that, and then you still get the same answer, all right? What basically I'm trying to say here is -1 times 10 to the power of 99 is the same as negative E. This is, how the calculator is programmed. So basically, it's the same thing. Instead of plugging that, the calculator will be able to recognize that you're looking for the smallest value the calculator can handle. Anyway, I'll move on to B. So B, what I want to find is probability that x is greater than 4. All right. So to find the probability that x is greater than 4, go ahead to the calculator, normal CDF. The lowest limit is 4. The highest limit is the highest value that the calculator can handle. Just plug in that. Those parameters are the same, and then you should be able to get your answer. So, which will be 0.309. All right. So out of curiosity, you may wonder, why are these two answers the same? Well, because if you look at the normal curve, all right, suppose this is the normal curve, and using symmetry, our mean is 3. Let's see. 2 is somewhere here. And then 4 is somewhere here. In part A, what you are calculating is this area, right? So basically what you are calculating in part A is that area, all right? And we found that that area is 0.309. In part B, we were calculating this area, and we find that that area is 0.309, which makes sense. So by symmetry, the area on each of those sides is the same. All right. Good. I'll move on to the next question, number 3. The heights of grade 6 boys at a large school follow a normal distribution with mean 151.6 and standard deviation 7.9. If a boy of this group is selected at random, what is the probability that he has a height less than 152? So X follows normal distribution with the parameters 151.6 and 7.9 squared. So the probability that X is less than 152 will be equal to, we just need to plug that in our calculator, same way. So second, that, look, for the CDF guy, the lower bound is negative, upper bound 152. The mean is 151.6, 7.9. And answer will be 0.520. Yeah. Yep. Good. For B, between these values, 150 and 157, you can plug that in your calculator. I'll leave you to do that, or I can just show you quickly. So, normal CDF, 150, 157, same parameters, 0.333. So 0.333. Great. I'll move on to inverse normal probability distribution function. So this is a function that returns the x value when you're given the probability, right? So basically it helps us to get the x value when you're given the probability. What I mean here is, suppose they've given you that probability, right? And they're asking to find this x value here. Then what you do is you use inverse normal probability distribution function. And it's inbuilt in your calculator, so you can basically use your calculator. Anyway, but what you have to remember is this function, it returns the x value for given the probability region that you're given, but to the left of the x value, all right? So to the left of the x value. So if you're given the value, the probability to the left of the x value, or the area to the left of the x value, because the area represents the probability, then you can go ahead and just plug in those values in your calculator. But if you're given the situation what you have below here, if you're given probabilities in the form of, in this form, then what you have to do is you must subtract the probability from 1 before you can use the inverse normal, right? So you have to calculate this probability. So if that is q, then you have to find this, which will be 1 minus q, right? Then you use those probabilities to find your answer. I'll show you in an example in the next page. All right, this is very important. All right, so let's see how we can use those how we can use the inverse normal to calculate this. So given that x follows normal distribution with parameters 1 and 3, find the values of a and b given such that the probability that x is less than a is equals to that. The best thing to do with these questions is start by sketching. Okay. Once you sketch, plug in the information that you know. So I know that my mean is 1, and this area is 0.506. That's more than a half, and it's to the left of A. So basically what I'm going to do is, I think A is somewhere here, because the area that I'm given is slightly more than a half. The area is 0.506. Remember, the probabilities here represents the area under the curve. Okay, now that I have this, and this meets the conditions that I set here, all right? So that means that condition. I can go ahead and now use my inbuilt inverse normal distribution to find the value of A. So basically, A will be equal to, I need to use the calculator. So if you go second distribution inverse normal, so the, of course you'll be asked the area to the left of A, which is 0.506. Parameters, the mean is 1, standard deviation is 3, and my A value here will be 1.05. Three significant figures is okay, so 1.05. Okay. I'll do the same thing for B. So sketch it. It's just a sketch, right? So after the sketch, of course, the mean is the same. So my mean is 1. I'm given probability to the right of B. So to the right of B, right? Call it the upper tail. So B is somewhere here. And the probability that I'm given here is 0.198. Now, what we said here is this. If you're given probabilities in this form, then you must subtract the probability from 1 before you can use the inverse normal. So what we have to do here is, we need to get this probability here. Okay, we need to get this probability. But to get that probability, what are we going to do? We are going to do 1 minus, so 1 minus 0.198, which will be equal to 0.802. So this area here, is 0.802. Now, because I have it in that form, in fact, I can write it here, probability that X is less than B is equal to 0.802. I can now use the inverse normal to find what B is. So you can now go ahead and use the inverse normal to find what B is. So inverse normal, my area is 0.802, same parameters, and my value of B will be 3.54. So 3.54. Great.